In our last video, we talked about graphing quadratic functions and x-intercepts and y-intercepts. And we talked about the fact that if you have an x-intercept, the x-coordinate of the x-intercept is the zero of the function. We're going to use that knowledge, those concepts, to look at a new concept, the concept of quadratic inequalities. Before we do that, let's kind of review a second here. Let's say that we have a function that looks like this, and we wanted to find the x and y intercepts and graph the function. So go ahead and pause the video, find the x and y intercepts of this function, write those as ordered pairs, plot the ordered pairs, and then graph the function. Pause the video and do that. All right, remember to find x-intercepts. That is where the graph crosses the x-axis. When you're on the x-axis, y is equal to 0. So to find the x-intercepts, let y equal 0 and find x. And remember, y is the same thing as f of x. So we have 0 equals x squared minus 3x minus 40. So now we have a quadratic equation, and we can run through our quadratic process. Do we have a b term? Yes, we do. So we get it equal to 0, keeping the x squared term positive. We look to see if we have any numbers to divide out, which we do not, and we look to see if we have any variables to factor out, which we do not. So then we factor. And because we have x squared, the only way I can get that is x times x. And because the coefficient here is 1, I can look at the negative 40 and think two numbers that multiply to give me negative 40 and add to give me negative 3, which are going to be negative 8 and plus 5. So then I set each of those equal to 0 and solve for x. And that gives me my two x-intercepts. And remember, those are ordered pairs. Literally what I'm saying here, when x equals 8, y equals 0. So we have the ordered pair 8, 0. When x equals negative 5, y equals 0. So we have the ordered pair negative 5, 0. To find the y-intercept, we let x equal 0 and find y. Because when we're on the y-axis, x equals 0. So that's the same thing as f of 0, which is just negative 40. So my y-intercept is 0, negative 40. I'm going to go ahead and graph this here on the next page. Hopefully you've already done this. You've already graphed it. So I have I'm just going to come down here and put negative 40, negative 5, 8. And notice that this negative 40 is not exactly halfway between negative 5 and 8. That means negative 40 is not my vertex. It's not the y-coordinate of my vertex. My vertex is going to be exactly halfway between negative 5 and 8, somewhere in the middle here. So when I draw my graph, I'm not stopping at negative 40 and coming right back up. I'm going down about halfway here and then coming back up. And as you can see, my parabolic graphs are not great. I'm mainly interested in kind of the general shape of it. There we go. That might be a little better. All right. So this is what our graph looks like based on our x and our y intercepts here. Now remember this piece of the graph, how high we are. If I have an ordered pair on this graph, this is my x and this is my y on any ordered pair, x, y on a graph. And remember y is the same thing as f of x. So what we're seeing here is that for the values of y above the x-axis, for this piece of the graph, over here and over here, all of those values of y are more than 0. They're positive. For these 2 points right here, we're right on the x-axis. That's where y equals 0. And then for all of this portion of the graph, all of my y's are below the x-axis. They're negative numbers. So what I'm seeing is that right here, right when x equals -5 and when x equals 8, y is equal to 0. For all of these values of x on this portion of the axis, from -infinity to -5, not including -5, y is positive. And then I see over here on this piece as well, in this piece of the graph, from 8 to infinity, y is positive. So that tells me that if I'm looking this as a number line, just looking at it as a number line, for the values of x from -infinity to -5, y is positive. For the values of x from 8 to infinity, y is also positive. And then in the piece in the middle here, this piece in the middle from -5 to 8, y is negative. So the positive values of y are above the x-axis. The negative values of y are below the x-axis. And this is going to help us solve an inequality. If I wrote the equation 0 equals x squared minus 3x minus 40, we've actually solved that equation already. And we got x equals 8 and x equals -5. So when I write an equation, I'm going to end up with two answers. Those are the values of x that if I plugged in and solved, it would equal 0. If I'm doing an inequality, let's say that I have that x squared minus 3x minus 40 is greater than 0. Greater than 0. I'm looking for the values of x that if I plug in here and here, I will get a number larger than 0, more than 0. That's what this means. Any number that's more than 0 is a positive number. So if I look back at my sign table, I can see that the positive y's occur when x is between -infinity and -5, and when x is between 8 and infinity. not including negative 5 and 8, because I have a strictly greater than here. So the solution to this inequality, if I said solve, that literally means find the value or values of x that make this a true statement. I'm going to look at my sign table and I'm going to select the intervals of x that give me a positive value of y, a greater than 0 value. So the solution here, my answer, is the interval negative infinity to negative 5, or the interval 8 to infinity. This symbol means or. It's a union symbol and it means or. Let's look at another one. Let's say I solve, and let's say that I have x squared minus 3x minus 40 is less than or equal to 0. Notice I have the same quadratic here. It's going to have the same zeros, negative 5 and 8. So I can use the same sign table. But now I'm looking for values of x that make this whole thing less than or equal to 0. So less than 0 means negative, or equal to 0 means equal to 0. So if I look back at my sign table, I look for where it's negative and where it is equal to 0 at negative 5 and 8. So that gives me the interval. My solution is the interval, the values of x between negative 5 and 8, including negative 5 and 8, because we want to include the values of x that make this equal 0. So that means if I plugged any number between negative 5 and 8 into this inequality, or excuse me, this polynomial, I would get a result that is less than or equal to 0. And I can easily check that. If I try 0, I get 0 is less than, or excuse me, negative 40 is less than or equal to 0, which is true. So I don't have to do that. I don't have to check that, but that just was a way to show you that I do have a true solution. All right, I've kind of come at doing this problem kind of backwards. We looked at the graph, we saw where it was positive and negative, and then we did inequalities. Let's look at doing a problem where we start with the problem and then we work it all the way through. So let's say my problem says solve, and I have that four x plus 3 is less than or equal to x squared. Let's make that 4x minus 3. All right, so to solve a quadratic inequality, the first thing is to get a 0 on one side. And we want to keep the highest term positive. In this case, the x squared. That just makes things easier when we get to the finding the 0 step. So I'm going to bring all of this over to the other side, and I'll have 0 is less than or equal to x squared minus 4x plus 3. Then I'm going to write with an equal sign and find the zeros. In other words, solve for x. Find the values of x that make this equal 0. This is not the same thing. Once I've found those, I still have to go back and do the inequality. So I want you to go ahead and find your solutions here. Solve for x. Pause the video, find x, and then start the video back up. All right, so I factored this. X minus 3, x minus 1. Negative 3 times negative 1 is positive 3. Negative 3x minus x is negative 4x. So I set each of those equal to 0. All right, so I found what values of x make this equal 0. Now I need to figure out which values of x make this positive and which make this negative. And there's two ways you can do that. You can use either what's called a test point, where you just put a value of x in and see if it's positive or negative, or you can draw a quick sketch. And I'm going to go ahead and do the sketch method because that reinforces what we've learned about graphing quadratics. So, because these are my zeros here, my solutions of my equation, I know those are my x-intercepts, and it's easy to find my y-intercept. It's going to be 0, 3. So I can go ahead and graph this quadratic. And I know whether it opens up or down, because the 1 here is positive, it opens up. So I can plot my points here. And I know this opens upwards. And those 3 points alone are not enough information for me to graph this, except I know already that it is a parabolic shape pointing upwards. And I know that my vertex has to fall halfway between my two x-intercepts. And it has to hit each of these 3 points. So that tells me that my graph looks something like this. And then I know that it is broken up into 3 intervals right here at my x-intercepts. And I have my 3 intervals, negative infinity to 1, 1 to 3, and 3 to infinity. And I can look at the picture to see where is the graph above the axis, here and here. Those are positive. And where's the graph below the axis? Those are negative, right here. So that has created my sine table. Now, I need to go back to the original problem. And I need to figure out which values of x, if I plug in, will make this greater than or equal to 0. That's what this means. 0 is less than this, so this is greater than 0. So that means I'm looking for positive values, and because it's equal values, equal to 0. So I want you to look back at your sine table here and choose the interval or intervals that make the y values positive and equal to 0. And see if you can write those interval or intervals. So I see I need positive because this is greater than 0. And the way I think about greater or less than, I look at my inequality and the big side is the bigger side. and the smaller side is the smaller side. So this means this has to be greater than this, which is a positive number. So I look and I see I have my positive values here and here. So I'm going to choose this interval and this interval. So my solution is negative infinity to 1. And right at 1, y equals 0. I do want equals 0, so I include the 1. Or this other interval, including the 3, so I use a bracket, to infinity. And that is my solution. So I didn't finish up my list here of what to do. Get a 0 on one side, keeping the highest term positive. Write it with an equal sign and solve for x. Create a sign table. And you can use test points. That's how they do it, I think, in my math lab, using the instructions there. And you can use either one, using test points or a graph. And then select your intervals. And that's going to be based on the greater than or less than. So if it's greater than, you want positive. If it's greater than or equal, you want positive and equal. If you want less than, and this is always less, greater than, or less than 0. If it's less than 0, you want minus. And if it's less than or equal to 0, you want minus and equal. Don't forget, when you're doing quadratic inequalities, if you have a greater than, a less than or equal to, any of those 4, you're going to be having intervals, and you have to show some kind of a sign table to see where you got those intervals.